Life on Earth didn't just appear out of nowhere. There was an origin to everything alive that exists today. You, me, your pets, the food you eat, the grass and trees outside of your house, everything has a common ancestor that we all evolved from. But we haven't figured out the first catalyst event that caused the first life form to be born. At one point, chemistry became biology, and every day scientists come one step closer to the discovery of how this happened. While we don't have the whole picture, we do have pieces that become more clear as we do more research. Nucleotides are long chains of oxygen, hydrogen, phosphorus, nitrogen, and most importantly, carbon. When these nucleotides form long chains, it forms RNA molecules. RNA is extremely important for life to form because these molecules can carry genetic information and can cause chemical reactions. Because it can cause chemical reactions, some scientists believe it may have been one of the first self-replicating molecules, which is huge when it comes to discovering when life began, as self-replication is unique to life and the building blocks for life. Most protocell jobs would have relied on RNA until DNA started forming, which is more stable, and replication became more efficient. This theory of RNA being the first of the main three molecules required for life, the main three being RNA, DNA, and proteins, is called RNA world. It's called that because it would have been a world with only RNA. It's a pretty self-explanatory name. It's still hypothetical, but it's the leading hypothesis as to which one came first. After RNA formed, DNA would have evolved and proteins would have formed, and both would help divide up the tasks RNA was doing so it wouldn't have to do it by itself anymore. An issue with the theory of RNA world is that, unlike DNA and proteins, RNA is not very stable, so it being able to not only exist and survive in such a harsh environment, but also be able to self-replicate seems highly unlikely. There's still a lot to discover, but as of right now, scientists believe the theory of RNA world is the most likely. Life requires repeated, self-sustaining chemical reactions, or an autocatalyst reaction. We have discovered catalytic RNA, or ribosomes. The ribosomes that we've researched so far seem to be slightly different than the kind required to kickstart the existence of life, but the current research seems to be bringing us in the right direction of understanding life's origins. Once replication became efficient enough, cells started working together and formed multicellular life. One of the more popular hypotheses for where life may have originated is deep-sea hydrothermal vents. The heat and chemicals may have created the necessary reaction to get RNA to self-replicate. Scientists also trace back the oldest common ancestor to marine life back to a species that lives near these vents at high temperatures. This theory is my personal favorite, mostly because I have a lot of hope that life formed on Europa, one of Jupiter's moons. NASA launched the Europa Clipper in 2024, which is set to arrive in 2030, and it will search for signs of life. If we do find life here, it would mean that life is likely abundant in our universe. The primordial soup theory is a more well-known theory, and I'm sure that even if you don't know exactly what it is, you've heard of it. Around 4 billion years ago, Earth's atmosphere had very low oxygen levels, and instead had more methane, hydrogen, ammonia, carbon dioxide, and water vapor. These chemicals in water would form what we call the primordial soup, which got its name because of the texture it likely would have had. When more heat or electricity was applied to this mixture, such as lightning, volcanic activity, or ultraviolet rays, it theoretically could have caused a chemical reaction that creates life. In the Miller-Urey experiment, scientists Stanley Miller and Harold Urey recreated this environment by mixing methane, hydrogen, ammonia, and water vapor in a heated pool, then sent electric charges through the gas. This recreated the Earth's atmospheric conditions from the time life would have formed. The results show that this experiment created 14 to 22 of the amino acids required to create life. This also gave credibility to the theory that proteins were the first building block to evolve rather than RNA, because amino acids make up proteins. It is important to note that these scientists didn't create life itself, but some building blocks for life, though this doesn't diminish the importance of this experiment or how incredible the results are. Another important thing to note is that the atmosphere having very little oxygen would be crucial because oxygen would break down any organic components. In fact, when the atmosphere started having increased levels of oxygen, it led to a mass extinction event, and I may make a video about that later on. The third theory is the theory of panspermia. This is the theory that life didn't form here on Earth, but rather came from somewhere else in space and traveled here via a comet or an asteroid or another moving celestial body. We've already found amino acids and sugars in space, such as on the Murchison meteorite, which had 80 amino acids, which is 60 more than what life uses on Earth. The asteroid Bennu was found to carry ribose and glucose, which is what RNA and DNA are made of, along with other building blocks for life such as carboxylic acids, amino acids, and all 5 nucleobases required to form life. This suggests that the ingredients required for life can be found out in space and could be plentiful. We also know that microscopic life is more resistant to outer space than larger life forms like ourselves. If we were to find life on Mars, it could be evidence for panspermia. Since the two planets are so close to each other, it would suggest that life formed on one and then was kind of spread to the other. We do share rocks between Mars and Earth sometimes, as a rock might kind of fall from Mars to Earth. This is different from if we were to find life on Europa, which is much further away, and we don't really share rocks between us and Europa, so that would suggest that life would have formed two separate times, which is why I'm personally much more excited about that potential reality. If life found a way to form on Earth once, could it have happened multiple times? There is no evidence of this. But if it were to have happened, it would have happened around 4 billion years ago, around the time that our last universal common ancestor, or Luca, formed. We know that all life today has a common ancestor. If you're eating right now, whatever animal or plant is on your plate is technically your very, 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 very distant cousin. We're able to tell by the similarities in our genetic code and our ability to kind of track evolution by looking at which species are more closely related to each other to tell that we are all related. This means if we've had multiple abiogenesis events, abiogenesis being the event that created life, there's only been one successful lineage. This means if we've had multiple abiogenesis events, abiogenesis being the event that created life, there's only been one successful lineage, and any other lineage would have gone extinct billions of years ago without even a fossil record, at least that we've been able to find. But considering we've been able to replicate different stages of abiogenesis, there is technically a chance it could have happened multiple times on our planet. With our current understanding, though, it is highly unlikely. Scientists who specialize in searching for extraterrestrial life are called astrobiologists. They study the atmospheres of different celestial bodies, such as planets or moons, to determine if they could support life. While we may not know exactly how life formed on our planet, whether it was a 1 in a million fluke or if it's a frequent chemical reaction, astrobiologists hope to find life in space. If we find what created life on our planet, it may help us gauge how frequent life could be found on other planets. If we find life on other planets first, it could help us figure out how our own lives began. It really just depends on which evidence we discover first. The James Webb Space Telescope, launched in 2021, uses infrared light to take pictures and detect chemical compounds in outer space. It orbits around the sun to study both our own solar system and other galaxies within its reach. It's like a leveled up version of the Hubble telescope. I'm sure you've seen some of the images it's taken, such as these. Last year in 2025, the JWST detected two chemicals on the exoplanet K2-18b. These two chemicals are dimethyl sulfide and dimethyl disulfide. The interesting thing about these chemicals is that we only know one way that they are naturally produced, which is by microscopic life forms such as phytoplankton. In fact, the odds of these chemicals being produced by non-biological means are 0.3%. which makes this planet a huge contender in the search for life. K2-18b also orbits within its star's habitable zone. While we don't know for certain that there's life on this planet, as there could be a lot of weird chemical reactions and a lot of ways those could happen that we just haven't observed, it's still so fascinating and so interesting and so exciting that we could be getting this close to discovering life. More than likely, when life gets discovered, it will be microscopic. I think intelligent life is probably extremely rare in the universe. For one, it would need to be evolutionarily ideal for another species to evolve intelligence. We evolved intelligence not because it was the natural next step in evolution and we're more advanced than any other species, but because it helped us in our environment. But no other species has followed us in that path. So why should we assume it would be prominent in the universe? You would also have to consider that, as far as we know, Homo sapiens have only been around for 300,000 years, which may sound like a long time, but our planet is 4.5 billion years old, and most estimates show that life first started forming anywhere from 3.7 to 4 billion years ago. That means that life has existed on Earth for almost its entire existence. But when you look at how quickly microscopic life formed, and how short we've existed and how long that took for us to evolve, it looks more and more likely that microscopic life could be prominent in our universe, but intelligent life could be extremely rare. The three things required for life to form are heat, which could be hydrothermal vents or lightning, like I explained earlier, liquid water, and organic chemicals, which just means carbon-based. All life as we know it is carbon-based. This means carbon is the primary atom that makes up life. Ribose, the sugar that makes up RNA, is made of 5 carbon atoms, for example. Carbon is especially good at bonding with other atoms to form chains or rings. This ability is called catenation. Catenation is important for an element to be adaptable. Since it's good at forming stable bonds, it can bond with the atoms required to make proteins and lipids and other necessary molecules found in atoms. If these bonds are stable, they can survive. This is a major reason why, for example, we haven't found silicon-based life or hydrogen-based life, though silicon-based life is considered in more alternative biological spaces and science fiction. Bonds with other elements aren't as strong or stable. Silicon comes close, which is why some people believe that it may be able to harbor life, but as far as we know right now, carbon is required for life. After all, diamonds are made of carbon, so that should show how strong these bonds need to be in order to support life. All life on our planet descends from Luca. We may not know exactly what species Luca was, or how long ago it existed, or if it's even still alive today, but despite this, we see the great-great-great-great-great-great-grandchildren of Luca flourishing today. Maybe we'll find our missing ancestor someday. Maybe we'll find the common ancestor for all life on a distant planet or a moon. Maybe someday we'll find our common ancestor, the very first life form on our planet, the one that started it all. There are pieces missing in our earthly family tree, but we continue searching while also looking for friends across the universe. I hope you find this as fascinating as I do, and if you do, consider subscribing because I plan to make more science-related content. Astronomy is my favorite scientific topic, and I'm especially fascinated by the search for life, which is why I wanted to start my videos off this way. If you like this topic, maybe consider giving my video a like. If you have any interesting facts to add, consider leaving a comment. I have my sources linked in the description below, so I encourage you to go check those out because there's a lot of really cool information that I didn't get to include in this video. I also encourage you to do additional research if you found this video interesting. Maybe you'll find something I didn't include here. Stay educated, think critically, ask questions, and have a good rest of your day.